All right, so let's get started. I guess we have a quite good forum right now. Once again, very nice to meet you. My name is Luiz Barboza from Webera. So today we're going to talk about the whole idea of DevOps, mainly its main concept, which is continuous integration, continuous delivery, in short, CI/CD. We're going to have a small demo here using GitLab. The tool itself is not the most important point, but of course, it's very interesting to see a practical demo. We at Webera, as AWS and GCP partners, we are very specialized on the all cloud products, especially on those services related to DevOps in terms of automation, continuous integration, continuous delivery. We have a very good level of expertise. So let me show a little bit about what I'm talking about. Talking a little bit about myself, I started my career back at the first wave of startups, late 90s. Then I worked for quite a long time as an IT architect for financial market, then telecom market. Then I moved to digital market once I was invited to Google Brazil to join Google Ads team. And that's when I met Webera and started to move to this cloud space. And then I specialized and get certified either AWS as a solution architect or in Google Cloud certified data engineer. A very short summary of Webera. Our main two pillars are what we call revenue protection, which is the idea to manage and keep updated customers' infrastructure IT environment in terms of hosting, security, managed service. And the other front is the revenue creation, which the idea to keep evolving and updating that environment, either in terms of new application development or what you're talking here today, which is DevOps, which somehow is the idea to automate and keep highly integrated with smaller release, more frequent release, with lower risk in terms of the environment, right? So the whole idea here is try to close the gap between the C levels and the IT teams, and not only between those two worlds, even within the IT team, there is a quite significant distance. Normally, in the traditional development or traditional infrastructure management, the IT operators and IT managers had to manage physical infrastructure in terms of servers, database, storage, or whatever, and which is something very away from what's the day-to-day of the developers. And the developers didn't know much about the infrastructure itself. The only concern was that the infrastructure were up and running so they could deploy their code. Now that we're talking on a cloud environment, the infrastructure is not physical anymore. It's a virtual concept that's managed and configured similar to what a developer does in terms of coding. In fact, the developers and IT operators now sometimes even use the same tools. For instance, they can use, I don't know, a tool like VS Code. That's something that we're going to use here for the demo. So they work very closely or in similar ways, and developers now have to have a better concern or better understand how the infrastructure is deployed on the cloud so they can make sure that the application is configured and developed according to the line architecture. So a little definition in what DevOps is. DevOps is exactly this, is a set of practices or culture that close that gap between development and IT operation. And the main benefit of closing that gap so is the company can work more focused on their business end and be more agile, more rapidly, reduce the risk in terms of new development, new deployment, new functionality. It changed that traditional idea of develop as a craft in terms of the developer produce a code, have this stable code, manually put in some test environment, then do a bunch of manual testing at some point during early morning or weekend or whatever. He can move that large chunk of stable version, eligible stable version to production. And the idea of DevOps is to have this a continuous cycles in terms of planning, coding, building, testing, releasing creating a stable package, deploy into production, and then be able to operate and monitor this continuously. And do it in small bites. Can even have daily deploys or even more deploys in a single day. Even have different versions simultaneous in production. That is a different number of techniques that can be applied so the risk can be reduced. And the whole secret for it is automation. So the idea is to minimize the amount of manual work, so minimize human error, and then can leverage all the service in terms of automation in order to minimize the risk, right? There is a very nice sentence here that I like very much. It's from a Spanish poet from the late 20th century, or from the 1800s and early 1900s, when he says that besides Black Hat, there is only automation. So he lived through the early initial stage of industrial revolution. And he's mentioned that everything can be automated. So if it makes sense over 100 years ago, also makes sense today. The idea in terms of automation is to have a more consistent process, independent of human tasks, have a single centralized platform, so being able to organize all these automations, be faster in terms of faster repair and faster actions in terms of your environment. In the end, saving everybody times, right? So that's the main point of automation. The whole process, he says here, I can do an analogy with assembly line or a pipeline. You could compare it with a factory, but of course here the end product that you're producing here are software. But here you can do an analogy with car production, in which you have different vendors producing body parts, engines, tires, or whatever parts. Then within the assembly plant, we assemble the car, send it to lab test, and once it's okay, can go to the car dealers to be sold, right? And the idea of the pipeline to software, to our CI/CD pipeline that we're going to talk, is exactly the same. The only difference here is instead of doing physical work in software, instead of being human doing all the manual work, it's done by automation process, automation scripts. So in terms of the car pipeline, you could have different stages. A very simple example here, you could consider a first stage in which the car chassis is assembly, and over the chassis you can deploy the engine, and finally put the wheels. Probably going to have other steps or the stage within this pipeline to assemble the body and so on. The same idea of having sequential stages of a task within the pipeline is the same idea that we're going to have to software. In terms of a software pipeline, the two main parts are exactly what you are talking here: continuous integration and delivery, or integration delivery. The main objective for integration part is to be able to compile and do unit tests within the package. So in the end of these stages, the idea based on a stable source that's committed to the developer, it automatically can be built and unit tested of it, and then the product of this part would be a stable package, regardless of the language or the technology that you're talking here. Could be Java, Python, whatever. In the end, you're going to have a stable package to be deployed in different environments. And that's the part when continuous deliveries come in. You can gather that package and deploy automatically in different environments on the user acceptance test environment, on the staging for performance test environment, and finally deploy to production. And within those, along with those deployment, could also perform a set of automated tests, either for performance or any kind of testing that you want to do. So as I mentioned, we could have those two halves of the pipeline: the integration pipeline, in which based on a stable code that the developer commits to the repository, we can build, do some code review if it's the case, and then run unit testing. Once it's okay, you can pack a single package that's stable. Then you can move to the second half of the pipeline, which is the delivery piece, in which I can deploy for different environments. I can deploy, for instance, for a UAT environment in which a human or a set of a specific team gonna manually review the stability of this deployment, and then move it automatically to a stage environment or performs test environment in which a stress test script gonna be performed and make sure that that the application is stable enough to a huge amount of demand, and finally move it to production. Within each step here, it's interesting enough that the main tools that encapsulate those pipelines, as GitLab that we're going to talk here today, they use a technology called containers. It's very interesting, but not only the tool that use containers concept in order to produce the pipeline, the output of this integration piece, this package could be executable or any kind of binary code, but could be also a container image, which is a very interesting option that's also very portable to be deployed in different environments. Just to make sure if you have an idea what I'm talking about, I'm going to simply review the idea of containers, especially when I talk about Dockers, which is the main containers technology. We could compare to what was the traditional infrastructure in the past, in which you had dedicated hardware. On the top of this dedicated hardware, you have to install the kernel and then install your application along with all the dependencies that they had. Not so long ago, we had this idea of virtualized infrastructure, the virtual machines, in which different virtual machines could share a single hardware supported by a hypervisor. And on the top of this hardware, shared hardware, we have to install the whole kernel, then the application with those dependencies. And then this container technology came along and push up the abstraction layer. Now we have abstraction layer of the container runtime on the top of the kernel, and you simply pack the application and its dependencies on a container, and you can move different containers or this little package with the application, its dependence from different machines very transparently. So we can get an application with those dependencies that was developed on a local machine of a developer and move to different operational systems, different hardware, doesn't matter. It's completely transparent from the application perspective, which lies below the container runtime layer, right? And a complementary technology is Kubernetes. Kubernetes do what you call container orchestration. So we have those containers, those packages. Now Kubernetes can perform as a crane. I like this image here, as a crane, where he can move these little containers to different nodes of servers, or they call clusters, cluster of nodes, each node being a server. And then he can scale up or scale down the number of nodes and deploy the according containers, or what he called pods, which is a set of containers with the corresponding application that can support the required demand of usage, right? So let's see the demo. That's the idea, to give a general overview. We're going to use GitLab. Again, the tool itself is not the most important point here. The main idea is this idea of continuous integration, continuous delivery, and how to automate the process. Just to make sure that you don't get very confused in terms of the names. So Git is the main tool for source control. And then we normally can have it to have a source control internal to a local machine. You can now also have the GitHub, which is a website, of course, for the same company, in which they have remote repositories. So if you have the source codes version control on your local machine, you can push it. The term is exactly this. It can push and pull version of your source codes to these central and distributed repositories. And lastly, we have GitLab, which is the whole pipeline in terms of continuous integration, delivery automation. Within GitLab, they have a small repository. You're going to see the main entry point for the whole process, actually the repository. So we're going to start do a little code, commit this code, or push this code to this remote repository in GitLab. And once he receives this code, that's the trigger to start the pipeline, right? So let's do this from the scratch. We're gonna have a very simple Python code, traditional hello world using Flask. Flask is a library of Python to perform web application. Then we're gonna build and create a package, and that package is gonna be in the end a Docker image of this application. And lastly, we're gonna deploy that package or that container on the cloud, on the Kubernetes cluster node. And interesting enough is that GitLab is highly integrated with Docker and Kubernetes. In fact, he has a whole heritage service within GitLab. So not only sources or binaries, you can register and save versions of Docker image within your GitLab pipeline. And it can also integrate with different Kubernetes vendors such as GCP or AWS, in which it can automatically triggers cluster creation, pods, containers deployment automatically within the pipeline, right? So let's see this in action. The example itself, it's quite simple in terms of concept, but there is a lot of subtleties, a lot of details. So as it's a live demo, if I made any mistakes, so sorry in advance. But anyhow, we can correct it, no problem. But let's do this. So I'm going to use VS Code as my IDE. I'm going to create a new project. All right, create the project, open it. So the first thing that I'm going to do is actually to create the application. So it's going to be a hello world.py. And I'm going to use the Flask library. So from the Flask package, I'm going to import the Flask class. I'm going to also use the functionality of showing the current time. So I'm going to import also datetime. And the code in Flask is very simple. Create an instance of this class Flask, and you have to set a name without any creativity. I'm going to use the same name of the program here. And then I can define a method, any name of the method, let's call it hello, which is gonna return a hello world message. And I can concatenate it with the current datetime now. Right, and the whole secret here with Flask is that he's able to associate different paths of your web server to different methods within your code here. So the secret here is using those annotations. I can add a route. So to the root folder, root directory within my web application, I can associate with this method calling here. And finally, I can associate with, once it started running, the main method, it can run our application. I'm gonna run to the local IP address, so that use that mask and put, I don't know, port 8080, I guess it's fine. So if I'm not typing anything wrong, I guess I have a good code here. Let's run it locally. So it's running locally. Let's see what happened here. Localhost port 8080. We have, oh, our hello world, and I guess I'm missing, oh, I typed it wrong. Let me put the different ports. All right. So here you have it, the hello world with the current date and time, right? So the idea in the end here is to produce a Docker image, right? In order to produce a Docker image, we have to use a Docker configuration file. Docker 5, never seen before, you have to define the origin, the base Linux image. So I'm going to use Ubuntu as a base image. Then I have to define all the steps once that image is created. So the first step is going to be actually to copy our source code to the root of that container. They run a couple commands. The commands that we need here is basically the ones that we require to support the application, right? The application that we use basically use Python and one of the Python library, which is Flask. It didn't have to do anything related to that because it's already was installed on my machine. That's normally exactly the kind of problem that containers can help with. Normally, the developer install a bunch of things, a bunch of dependencies of the application. You don't remember that at all once they have to move to a different environment. So everything that they have as a dependency of my application, that's the time that you have to explicitly declare to the container. So I'm going to use apt-get to install Python, and then Python pip, and then use pip to install the Flask library. So apt update, and then apt-get. Install Python 3, the developer edition, which is a little shorter, and pip. Then we're gonna use pip to install Flask. And finally, gonna have Python 3 as the entry point, and the command to start once the image is started is our hello.py. If I didn't type anything wrong, I guess we have a solid Docker image here. Seems okay. All right. And lastly, in order to describe that pipeline, we're going to use a configuration file that GitLab provides or reference, which is a YAML file. YAML, it's similar to this kind of configuration file. It's similar to XML or JSON. Actually, the acronym means yet another markup language. So it's a markup language to describe, on our case, a pipeline of integration and deployment, right? The name of this file is .gitlab dash CI YAML, right? Within that file, we're going to describe all the stages that our pipeline has. Our pipeline has basically 3 stages, which is build, in which we're going to build the Docker image. Then we have deploy, we're going to deploy in a cluster node. And finally, we're going to test it, right? So for the first stage, I can call it whatever name I want. I can call it, I don't know, build app. And here, that's interesting that GitLab use as each step or each stage of this pipeline, the environment you use to execute the steps or the script that I'm going to describe here is actually a single container. You could do an analogy with the physical world. Let's assume that you're assembling a car or whatever. You have a garage that going to work, and once that garage is finished, and you could use actual physical container as a garage, it would be equivalent to do the assembly of an engine or whatever within a physical container, and once that that messy work is finished, we can recycle or destroy completely the container. Of course, the physical world is more complicated, but as we're talking about software, it's much more simple. So for it, in summary, for each step, each stage here, GitLab is going to create a container, do all the steps, all the scripts related to that stage, and once the product is produced within that stage, he destroyed the container used to that stage. So in that sense, you have to define what kind of image do you want to use for that stage step. As here, we're going to mainly create a Docker image and push it to the repository. I'm going to use an image that's based on Docker. Then I have to describe which stage I'm talking about. That's how and when I can link with these 3 steps here. I have to associate this very same name. So I have to have build here. Then if I'm using the internal service of GitLab of Docker register and so on, I have to define that here. So I'm gonna describe that and use Docker. It's a stable version of it. And then finally, I have the script, right? The script is going to be basically 3 steps. The first one is to log in on the Docker registry. Then I have to build the image, and finally I have to register the image on the repository. So let's see GitLab. So that's the main script for GitLab. So the first thing that they're gonna do here is create a group. So all your projects lives within a group. Let me call it whatever name. Demo GitLab US. Let me set it public. Within a group, I can create projects. Demo GitLab project US. Also public. And here you can see, as it's the first page of the project, it's actually a repo, right? So it has the URL for this to access the repo. And as I mentioned, once you commit a source code to it, it triggers the whole pipeline. But what I want to see first is this. We have the service in which can register package stable binaries that was assembly within the pipeline, and also containers. So there's a whole container service within GitLab. And here it shows the path to that register, actually the actual command to build and push. And then I'm gonna simply copy and paste it here. The command is simple enough. The command is docker build minus tag. So define the name of your image, which is a path to the registry service. And the push, it's quite similar also. The push is docker push and the name of the service. The last command that I have to check here is the login. The login we probably can access. Let me copy. It's a standard string to use the environment variables that can access automatically the repository. I have it here. Just a second. Here it is. So it's Docker login, and the username and the password, it's actually set as environment variables, right? So I can Docker login minus U for the user, and the passwords, it's a, it's an environment variable. All right, I guess we have it. I guess we have it. And then the next stage on our pipeline is going to be deploy, right? Can define whatever name I like. Then I have to define the image. And the main step in deploy here is to get that, Docker image and deploy it on a cluster node on Kubernetes, right? So basically here I need an image that has Kubernetes client, kubectl, right? We here in Webera have actually an image of our own, which is this one. You can create your own images. We have one of our own for this. Also here, as we're deploying, you can define what environment you're going to deploy. So we're going to define the environment as production here, production, environment production. And let's create the production environment within GitLab and also integrate with Kubernetes. Let's do this. So here, the operations menu, have the environments. Let's create a new environment called production, that's it. And also here on operations, you have Kubernetes, and you can add a cluster. You can integrate with AWS on EKS or Google GCP, GKE, right? When I use Google, I can define whatever name of the cluster I like. Set it to deploy associated with the production environment. Let's select whatever project I have on GCP. I'm going to use US Central Zone, 3 nodes, and the standard machine. It's going to take a while to create, I don't know, a couple of minutes, and can get back here and review what you've done so far. Again, we are defining a pipeline with 3 stages. The first stage of build, the main idea of build is to create a Docker image of our application. In order to have the Docker image of our application, we describe that on the Docker file, which have the copy of our very simple application, along with the steps to install all the dependencies required to run that application. And finally, the last command to call or to get our application up and running, right? And now we're starting to define the deploy stage, which is to get that container image that you created and deploy on a cluster node on Kubernetes. So the first thing is to define what environment we are talking about here. The main environment that you're talking here is production, right? And then we're gonna have to associate with the name, right? It's associated with build. Here, this stage is to deploy. And then you have the script. The script is 2 steps. The first step is actually to deploy the container, the pod on the container node, and Kubernetes deploy container or pods on nodes. But if you want to expose those services to an external world for a public port, public IP, you have to enable a service layer. So that's the 2 steps that we're going to do here in Kubernetes. So using kubectl, we're gonna run, deploy our hello application based on the image of this guy, kubectl. Here gonna expose the service hello on port 8081, and it's gonna be of the type load balancer. So if you have different nodes with different deployments, so in that node, every user flow that comes through that port can be distributed according to the policy of this load balancer. Right? Those are the two steps that you have here. I assume that the nodes are still being created. Anyhow, let me see here on GCP. Yeah, the cluster is still being created. Anyhow, going back here on the first page, on the home page of the GitLab, I can see here the URL for this internal repository, right? So if my code is complete, let me double check if I'm making any mistakes. Any typo here, gonna waste a little bit of time, but no problem, I guess. It seems fine. All right, the Docker image is fine. So let's save it on GitHub, and then I can push it to this remote repository here. Yeah, the cluster is up and running. Let's push our code and cross our fingers. So let's push it to this remote repository. And here on GitLab, we're gonna change the screen. Here now, instead of the instruction to connect to the repo, we have the file that you just committed to the repo. And once I've committed those sources, here we've been on CI/CD, you have the pipelines. Let's see what's happening. So it started already, the pipeline. Let me see what's the status. So the pipeline, as predicted, has the build stage and the deploy stage. Let's see the build stage, how is it running. And as I mentioned, in order to, every single stage of it, it's actually a container. So it's putting up the initial container, which is a Docker image. And within that the Docker image, we're gonna run those steps that you defined here, right? Where is it? The login, the Docker build, and Docker push. Let's see how is it going. Guys, any doubts, any points, please feel free to type on chat. If it's the case, I can even open your mics. Of course, the whole demo here is the idea to do the simplest thing. But in terms of performance, there is a lot of techniques that can be done here, as using cache for those containers, those stages, and have a more speed up process for the whole process. So it just finished the first step in terms of container registry, right? So we're gonna have here the image that was built. It's available here on the internal registry. And going back over there, let's see the second step of the pipeline. It's already running, the deploy step. Oh, I typed something wrong. It's double dash over there. Let me see if he put anything here. Let me erase whatever he puts. Yeah. So here it's a single dash. That's the kind of detail that I was talking about. So let's commit to this version and push it to the remote repository. All right. And interesting enough, you can see here a single execution, a single instance of the pipeline. So it failed the first one, it's running the second one. The whole build process is going to take a little while, a couple minutes again. Just keep in mind you are still missing the last step of our pipeline, which is test. The test script is going to be very simple. We're going to use a very simple Linux tool. It's curl, probably you know. The idea of curl is to more or less emulate a browser. You can connect to our web application and make sure that it returns a OK code, a 200 code. If that happens, we are fine. We consider it as a good to go. It's the simplest test that I could think of for this presentation. But of course, in terms of threat strategy, could be much more complicated. Even within the build stage, we could put along with the source code a bunch of unit tests that could run and double check if the application logic is sound. And then an afterwards process on the delivery process, we could provide a whole bunch of stress tests or different kind of automated tests that you like. So I guess it's finishing. Yeah, finish that stage. Let's see the next one, and I hope it goes fine now. Oh, another type load balancer. kubectl expose deployment hello port 8081 dash type load balancer. Oh, yeah, again, another typo here. 2 equal sign. Sorry for the typos, guys. Deleted. commit it and push it again to the remote repository. That's third time's a charm. All right. So yeah, it's running already the bit stage. It's finished. Finishing. Doc build is probably doing the push at this point. Yeah, push is finishing up in the first stage. All right. Let's hope that the second stage finally goes fine. And interesting enough, the comment that I do, so commenting our commits, it's important now. The name of the comment that I do on the commits is actually the name of the title here for this version of the pipeline. So I put okay. So that's the title here. Let's hope that's actually okay. Yeah, sounds perfect, succeeded. Let's see our Kubernetes environment here. We have the cluster. That's was already up and running. Within the cluster, we're probably going to have the deployment. The deployments, the workloads, the deployments are up and running. Let's see if the service layer is available already. So it's creating the endpoint here is still. Let's wait a couple seconds. Still creating. Once it's created, gonna present as an external IP address with using the port 8081 that we define. Yeah, here it is. Actually gonna copy it using my test script. Still putting the application available. Here it is, our hello world, right? Let me delete it and do the last step, last stage of our pipeline. Deleting. All right, and the last step is going to be very simple. We're going to be test application. The image that we're going to use is going to be one of the simplest Linux distribution, which is Alpine. I have to associate with the stage. The stage is test, and then the script going to be something script going to be something very simple. Echo testing. Going to install curl. Again, curl is that little tool that can connect to the remote servers, to web servers. installation of a package here on Alpine is a little different than in Ubuntu. Unfortunately, it doesn't has apt-get, which is fantastic. Then I'm gonna, as the deployment take a while, I'm gonna put to sleep, I don't know, 3 minutes, and then run the actual test script. So curl, include the headers, do it silently to the URL that we received, and get the first line of the header. And let's check if it contains the 200 code. That's gonna assume as everything's all right. All right, I guess we have everything here. Cache. All right, let's commute. Being confident enough to be the final version. Let's hope it is. Let's hope I'm right. And push it to the remote repository. So it's pushing already. Let's see our pipelines. It's already running. Probably at the initial stage of the build stage. Guys, any doubts, any points? We are finish up on time. We're gonna probably finish within the time frame. In like 5 minutes or so, we're gonna finish. It's the last demo. I want to take the moment for ask any question, any doubts. If you'd like even to open the mic, I can do so. But if everything's fine, that's the whole idea that I want to present today. Again, it's a very simple example. It was interesting enough that was actually done from the scratch. You could actually, in live, you could actually see mistakes and typos. That's the real word. But it's a very small, very simple, but a very interesting demo because the package that's produced, it's very interesting one. It's a Docker image. It's very useful in terms of moving around and being portable. Then we use the feature of GitLab, which is interesting also, that within GitLab, besides the repo, the internal Git repo, it has container registry within the GitLab, which is very convenient. So you can create and build those container images and have it register within the pipeline itself. You don't have to push to external repository, either on GCP, AWS, or even Docker Hub. And then we use another technology that's very interesting, very integrated with GitLab, which is Kubernetes. As you could see, it's possible to integrate it with either AWS Kubernetes EKE or GCP Kubernetes, which is GKE, right? We're using GKE here, deploying the pod, deploying the package, and then exposing the service with that second command. And lastly, doing, of course, a very simple test. The test could be something else, something more complicated. I'm simply doing a connection with curl to see if our application is up and running on the production environment that we decided to deploy. But again, it's quite simple, but at the same time, very interesting, showing very useful resource. At first, this whole idea of working with, oh, it's already deployed very fast this time. Yeah, so I deployed in the testing step. It's probably going to take away all that sleep timer that I put. So the main points are those, right? We are producing a Docker image, it's very portable, very interesting. We are also using the Docker registry that's available within GitLab. And lastly, that seamless integration between GitLab and Kubernetes, which is very convenient enough, right? So I believe our service probably have here already the cluster. It's still up and running. The deployment seems fine. The serve it's exposed already. I assume that our application is already, oh, that's not what I wanted to do. Yeah, I believe our application is already up and running, or it's starting at least. That's the actual time that we need here. That's what the sleep step have. It's present here. So can wait a little bit if Kubernetes needs a couple minutes to have the application actual up and running. Can wait for it and then run the code command to make sure that you have connection, right? Couple more seconds, then you can finish on time. I can, in the meantime, present here my contact information. Guys, that was a pleasure. Please feel free to reach me. Feel free to reach us. We are very love to talk about your cloud environment, of our current development process, see how this kind of process of CI/CD can address some of opportunities that you can have, right? Again, I'm showing my contact information here, and let's see that our process is finish up a couple more seconds and you are good to go. If you guys don't have any doubts, I can finish up right on time. Appreciate it. Yeah, that's it. That's it. So we connect to the remote server to return the 200 code that expected, and we present our very exciting message of website or our application. It's okay. So guys, once again, thank you. I I went over 2 minutes of our time. Again, if you have any doubts, any points, please feel free to reach me. It was a pleasure. Thank you for having me. Bye bye. Thank you very much.